Okay, so welcome to 2.8. This is adding and subtracting rational expressions. Learning target 9, like we're looking at adding, subtracting rational numbers again by using the same rules as with numbers. So we remember, like, how do you add fractions? And so we actually go back to, like, how do you add 1/2 plus 1/3? And so based on what you know about adding 1/2 plus 1/3, why don't you add 1 over x plus 1 over y? And so you can try that question on your own and pause the video, and then we're going to talk through it. And so, of course, the way we add two fractions together, like 1/2 and 1/3, is we need a common denominator. The only time you need a common denominator, multiplying and dividing, is you don't need it. Adding, subtracting, you do. And so factoring is still going to play a huge role in this to actually get that denominator. So we multiply the top and bottom by 3, and multiply the top and bottom of the second one by 2. And so we end up with like 3 over 6 plus 2 over 6. And then we just add the numerators, leave the denominator the same, and we get 4 over 6. And then we reduce it afterwards, and we get 2/3. The reduce after is actually going to be part of rational expressions as well. And we always have to check if we can reduce after. So similarly, we've got, like, multiply the top and bottom by y, multiply the top and bottom by x. Your common denominator is x, y. I always say, like, with rational expressions, it's almost even easier than numbers, because we don't even actually have to, like, evaluate them. We just leave it as x plus y. I can't reduce that because we don't know what it is, and so we just leave it as x plus y over xy. We do still have to state restrictions. X can't equal 0 and y can't equal 0. The nice thing about restrictions with adding, subtracting is that whatever the restrictions are in the top, like, they're usually just like they're pretty easy to see in the factored form at the top, and then they are the same restrictions throughout the bottom. And so x cannot equal 0 and y cannot equal 0. And actually, like, unlike in multiplying and dividing, they'll actually be easiest to see in the top. So just going to work through some examples. We got here 5 over 2a, 1 over 3a. The way we're going to do this is we're always going to state what the lowest common denominator is first. That helps you, like, understand that, like, we don't find common denominators just by multiplying the denominators together. It's a myth. That's something that just makes things more complicated. The common denominator between, like, 4 and 6 is not 24. It's 12. And so it's really important that we kind of talk about that idea of a lowest common denominator, not just multiplying them together. And that's factoring is going to play a crucial role in that. So our lowest common denominator is 6a, not 6a squared. 6a squared is just going to make your life more difficult. So do it as 6a. And just like in the warm-up, we're going to say multiply the top and the bottom of the left side by 3, multiply the top and the bottom of the right side by 2. So you got 15 over 6a and 2 over 6a. So you got 15 plus 2, just add the tops, not the bottom. And we're left with 17 over 6a. Our restriction, just like in the top, we've just got a cannot equal 0. The second one, lowest common denominator is not 5y cubed, it's 5y squared. Like, this does not need, this one does not need another y. This one only needs one y, not 2. And so the lowest common denominator is 5y squared. So multiplying the top and the bottom of this one by 5y will get that common denominator. So we got the top here, negative 7x multiplied by 5y. The top denominator is 5y squared. Here we just leave it 3x. Pushing everything together, realizing that negative sign, that's going to play a key role later. So just be careful with that negative sign. We got negative 35xy minus 3x. There's nothing really you can do here. You could factor out an x. I just want to talk about that. Like, we don't have to here because it's not going to cancel out. So if you can factor something out and it'll cancel out, then you should. But if you can't factor it out, if it doesn't cancel out after you factor it, you don't have to. It's good practice always to factor it, because like even though we're not graphing these, factoring the numerators does tell you a little bit more about the shape of the graph. So here we just say y cannot equal 0. That's just from the tops. The third one, -1, and whenever we have minus a constant, this is like what makes it a rational expression is like the first guy. And so like we are adding, subtracting here, and so we just recognize that like the second one is like the lowest common denominator is still 3x. The second one is just 3x over 3x, which is 1. Numerator is x plus 2 minus 3x. You're going to combine like terms, we get negative 2x plus 2. And again, just like in the last one, we don't have to factor out the 2 because it's not going to cancel out. And so we just say x cannot equal 0, and that's our restriction from the top. If I'm going too fast, please just like pause it, take your time, like work through it on your own, and then just kind of watch the video. Lowest common denominator here is the product of the two denominators, because there's like no factors in either of them. They're all factored. And generally, if everything's factored, like you are going to get the product of the denominators. So it's 5 times x plus 4. The left one needs an x plus 4 in the top. The right one needs a 5 in the top to get that common denominator. 2x plus 8 plus 15 is the numerator now. 2x plus 23 is when you add 8 and 15. And nothing can factor, so we just leave it like that. And x cannot equal negative 4, just like in the very top line, x cannot equal negative 4. In general, like unless like on the on this line here, if you cancel something out, maybe it goes away. But like in general, the restrictions are like pretty straightforward right from the question. Lowest common denominator, you've got the product of the two, a minus 3 times a plus 2. So the first one needs an a plus 2 in the top and the bottom. The second one needs an a minus 3 in the top and the bottom. And so we got the same denominator on both times. Notice this negative sign. It's very important. Like, you be very careful with this negative sign, because we're subtracting everything here. When we expand this, we're going to get a trinomial. If we subtract the entire trinomial, we're going to have to distribute the negative sign. So one thing like it might be helpful is when you write it again, just write brackets around. Like, you don't have to write brackets when you expand this, but keep the brackets around here when you expand it out, like this. A squared plus 3a plus 2. Then you got a squared minus 10a plus 30 plus 21. Then you can see that you have to distribute that negative sign. You can like combine like terms at the same time. A squared minus a squared 0. 3a plus 10 is 13. 2 minus 21 is negative 19. Hopefully, if you write the negative sign with the brackets, you won't forget that you're subtracting each one of those numbers. And nothing can factor in the 13, so it's not going to be able to reduce any further. And then your restrictions are really right from the top. A cannot equal 3 and a cannot equal negative 2. So not as much canceling out here as was the case before. The next one, please don't make the mistake where you say the common denominator is a product of these two. Like, it's just a mess. Like, it's way more work than you need to do. You need to factor it first. So always factor before deciding the LCD, so that way you can see what the lowest common denominator is, not just what a common denominator is. So we got a plus 3 and a plus 2 in the bottom left, and then a plus 1 and a plus 2 in the bottom right. Lowest common denominator is a plus 3, a plus 2, and a plus 1, not a plus 2 again. If you just multiply these two together, you're dealing with like a plus 3, a plus 2, a plus 2, a plus 1, and you just have too much. The left one needs an a plus 1, and the right one needs an a plus 3. Again, we just write it out as subtraction. I'm going to kind of push things together here because it gets to be a lot of steps, but I want to show them all. So we've got the top here and the right here. So we got subtraction in the middle. I got a squared plus 2a, or a squared plus a minus 2a minus 6. So again, the negative sign gets distributed to both those numbers. Common mistake is just to put it on the one number. Combine like terms, we got a squared minus a minus 6. And we got something kind of intriguing here. Nothing before, we could never really do much, but possibly we have a trinomial that can factor. And so just playing around with it for a little bit, we see that like -3 and +2 would work as nice factors. And if that's the case, then a plus 2 actually cancels out. It becomes a hole in the graph. It becomes really interesting. Like the answer becomes a lot different. A minus 3 over a plus 3 times a plus 1. Something in advanced functions that we're actually a lot more comfortable graphing. Not this year, but in grade 12, we're very comfortable graphing something like that. And then that's done. You can't cancel out a minus 3, a plus 3. And so you state your restrictions. A cannot equal -3, -1, and -2. That really just comes from the lowest common denominator. It's the restriction. So you could say that the lowest common denominator gives you restrictions. Okay. Just one last note here. I just want to point this out. This is another common mistake that students do. So what they did here was they actually in good faith, trying to find a common denominator, adding 1 to the top and the bottom here. And by adding 1, they said 2 over x plus 1 plus 1 over x plus 1 equals 3 over x plus 1. State the restrictions properly, 0, -1. There's something fishy going on here. Where did 0 go? X can be 0 on the bottom. So it tells you that possibly you did something wrong. What else tells you that you did something wrong is if you tried to do this with numbers, it wouldn't work. 1 over 3 is not the same as 2 over 4. You can't just add the top and the bottom of 1. And so you've got to be careful with these ideas. You're avoiding the fact that the lowest common denominator is x times x plus 1. You're missing some of the multiplying the top and the bottom by stuff. And so you're really changing the skill level of the question, and it's not correct. These are not equivalent. Student found a common denominator between adding 1 to the top of the first fraction. You can't do that. 3 over 2 is not the same as 4/3, and the answer when adding should have the same restriction as the question. That's actually something we've seen develop throughout the lesson.